Welcome to another physics video. We're going to be looking at momentum in 2 dimensions. So we've got a question here. Let's answer it and let's understand. In a snooker game, a green ball of mass 23 grams moves towards a stationary yellow ball of mass 23 grams. After the collision, the green ball moves with a velocity of 1.5 meter per second at an angle of 30 degrees to its original direction, while the yellow ball moves with a velocity of x meter per second at an angle of 60 degrees to the green ball's original direction. Calculate the final velocity of the yellow ball. So to help you understand better, I want to show you this in real life. So I have a set of a snooker game, or billiards as some people call it. So let's see the situation in real life. So we can see here the collision in real life. Now I'm going to slow this video down to 0.2x, and we can see the green ball moves in the horizontal direction and collides with the stationary yellow ball, and they both move off with a momentum. Now, the reason I'm showing this is because a lot of the questions you get in the exams are going to be very similar to this situation, where you have a ball colliding and they both move off in opposite direction with different momentums. And then they ask you to do some calculation. I've shown that same thing again, but with an axis and the angles that they form with that axis after they collide. So now let's get back to solving the question. So we're going to use the conservation of momentum principle. The total initial momentum is equal to the total final momentum. Now, since we're talking about 2 dimensions here, x and y, we have to talk about the x and y directions. So momentum in the x direction initially is equal to the momentum in the x direction finally, and momentum in the y direction initially is equal to the momentum in y direction finally. Okay, now what we can do is we want to consider the y direction specifically here because we don't have enough values to use the x direction. So I'm going to have the momentum of green ball in the y direction initially plus the momentum of yellow ball in the y direction initially is equal to the momentum of green ball in the y direction finally plus the momentum of yellow ball in the y direction finally. Now what I'm going to do is we know momentum is equal to mass times the velocity, so I'm going to plug those in here. So expanding the momentum, we get the mass of green ball times the initial velocity, mass of the yellow ball times its initial velocity, mass of green ball times its final velocity, and mass of yellow ball and its final velocity. Now we know that the initial velocity in the y direction for both of them are 0, so the initial momentum basically is 0. So our equation will be looking something like this. I've also put in the final velocity of the yellow and green ball, their components in the y direction specifically, and now we're also going to move the yellow ball term to the other side, and we're going to be getting an equation that looks like this. So now what I'm going to do is I'm going to make the velocity of the yellow ball the subject, because that's what I want to find out, and I'm going to get this as my expression for that. So now what I'm going to do is I'm going to plug in the values. So that's going to be 0.023 times 1.5 times sine 30 divided by 0.023 times sine 60. And we're going to get our answer as 0.866 meter per second. Okay, so that's all for this video. I hope you enjoyed it, and see you in the next exam walkthrough.